Okay, it's integral of a rate function is, again, like I said, big deal because it is one of the applications of integrals. So if we're going back to the fundamental theorem of calculus, let's say we have some derivative. What is the output of that according to the fundamental theorem of calculus? S of t evaluated from 0 to 4, which is, so you have s at 4 minus s at 0, which is going to be a net change in something, depending on context. Okay, it could be how much grass is decomposed, it could be how much gravel is processed, it could be how far cars traveled, anything of that nature. Okay. But the key here is that you have a rate function or a derivative. It's not very equal. Okay, and you are calculating the antiderivative. You're just undoing it. Okay, so I'll go through a few examples with you, and good.
So indefinite integrals give us the actual position function.
Oh, there's a 5.5.
Yeah, and if you have an initial value, you just calculate that. Okay, so we can do this with functions or tables or graphs. Okay. Tables and graphs usually come in the form of estimating with Riemann sums or trapezoidal sums. Here's a function. Okay, water is leaking from a tank.
Yes.
This one.
Yeah. We have our typicals, don't we? At a rate.
You just can't tell all the time.
Here's a joke.
Oh, let's do it in hours. That's pretty fast.
Oh, is that 2 plus 5?
2 plus 5t.
Liters per hour.
T is the number of hours after 7 a.m. Apparently they know when the leak started. How much water is lost between 9 and 11?
AM, like you said.
What did you say?
AM, I'm assuming.
Yeah.
I would exponentially.
Could be PM. So-
Exponentially, but
The reason that this changes proportionally is because the more water you have in a tank, the more pressure there is at the bottom. Okay, every 2.3 feet that you go up, you add 1 pound of pressure. Okay. So as the water level drops, the pressure drops where the leak is, and the water flow is going to slow.
pressure isn't,
Okay.
you could have a large volume, but it only being so tall, and pressure would be the same as.
Vertical height is the only thing that matters. Yeah. Like for irrigation, our system is gravity fed, and we have we have about 200 feet of drop at our bottom valve, so we have about 90 pounds of pressure. You could set the ocean on top of that, 200 feet deep, and it would have the same amount of pressure. Yeah. So what is our setup? So we have a rate, right? Rate function.
Right.
And we want how much water is lost. This is a net change. Okay. So what do we need to set up?
The integral of
9/11.
2 to 4
Oh,
plus 5.
right.
Yeah, be careful there, because it's after 7 a.m.
Yeah, so it is super.
Okay. Now, when you're writing these questions out, please do not forget your dt or dx. Okay, you can get in some, if you miss this and you put equals and then things, it's not mathematically proper. Okay. So what do we get here?
2t plus 5t squared over 2.
You know how to evaluate that, right, Efrain? Top first.
Yeah.
We should get negative 34.
What? Oh. That's it.
Oh.
Huh? No.
Why would that be negative?
Because it's
Oh, it's water is
Here,
lost.
let's see.
So
This
you're-
is the mathematical answer. Let's talk
yeah,
about
but
that.
then you have to
Okay.
think contextually.
So contextually, what would you say if you were asked to explain?
34 liters are lost between 9 and 11 a.m.
Yeah. Of water. So that would be your contextual explanation. Sometimes that will come into play. Okay. Questions? Okay. There is a question, an example in your book about using Riemann sums. I'm not going to take the time to do that, but Riemann sums. The nice thing about using a table in Riemann sums is that they say calculate the Riemann sum. They tell you what to do and they'll usually ask you to explain. So, let's talk about velocity function over a time interval. So if I integrate a velocity function, if we get an output of position change, right? This is a position change. Okay, of what kind?
Displacement.
You sure?
Yes.
Is he right?
Yes.
Are you guessing?
Yes.
Just because it's Montana?
No, it's right, because like, if you think of it like as a Riemann sum, you'd add the positive and the negative, and that's displacement. To get distance traveled, you have to like find the intervals where it changes from positive and negative.
Right. Okay, so no absolute value. You have positives and negatives, correct? So you're going to get some movement backwards. Right? Now if we're looking at something like this, that is where we have distance traveled. Okay, because these are all positive values. It just keeps adding values. Right? Think about, like, start a parachute, go to Denver, back to Glenwood Springs. Okay, your displacement is only
The distance from Fairfield to Glenwood.
there. Okay, because we subtract out this right here.
So last year, didn't we like split them into 2 intervals?
Distance traveled, both of them. Yeah, so
Done that yet?
if you are dealing with this without a calculator, you have to split it into two integrals where there's a negative.
Well, if we have a calculator, you can just do,
You can just put that in,
really?
absolute value bars, should do it for you.
Yeah.
Let's do you want to do a distance traveled one?
What?
Do you want to do
Yes.
one of these?
For example,
Let's do the particle. These are particle motion problem. Travels or has velocity. V of t equals so there's your velocity function. Let's find the distance traveled. Over 0.6. So we need this right here.
I forgot how to split it up.
Backwards. Okay, the question is there a spot where it's negative? So how do we calculate where there might be positive to negative sign
So you
changes?
said it equals 0.
Yeah, so we're gonna set velocity equal to 0.
Looking for sign changes, correct?
Yeah, so,
I got a T.
greatest common factor, and then what is that factored out? T minus 6 and T minus 4. So T equals 0, 4, and 6, right? Where, okay. The velocity at, let's say 1 is what? So we do a sign analysis to determine positive or negative. Okay. Positive, yep. And velocity at, let's say 5 is negative.
Probably negative.
Positive, negative, positive, and negative, yeah, so that tells us where to break up our integral.
So, 1, 0, 4, and 4 to 6.
So we have the integral 0 to 4, d of t.
Is it still absolute value?
No, because this is positive. We know that's positive, right, 0 to 4. Minus,
4 to
Yeah.
6. 4 to 6.
okay,
Do you have to have the DFT twice?
yeah,
Or-
you should. Okay. Subtracting, we can take the absolute values away because you'll get a negative and a negative, which is a positive off the back end.
If it was the 0 to 4 that was negative, would you write it as the integral 4 to 6 dt minus?
You could.
0 to 8?
Yep. If you do all the work there, you would get 49 and a third meters. Good.
Yeah.
Okay, make sure you have a calculator. The next one's gonna be a calculator problem.
Smartest school supply purchase is a calculator. That's right. I had mine
Okay,
last
so,
year.
number one is calculator friendly on the AP exam, correct?
Yes.
Right, so the first thing that you want to do is put the function in your calculator, making sure that you typed it correctly.
We did this in the y equals?
Yep.
Oh, Lordy.
Make sure you type it right, and also make sure that your calculator is in radian mode. Because we have lots of people using those.
Okay. Find G prime 5 using the
Holy moly, I need these glasses.
Okay, so 90 plus 45 cosine t squared or 18.
Yes.
Okay. All right, you good?
Yes.
Okay, now let's do some annotating here. On a certain workday, the rate function in tons per hour at which unprocessed gravel arrives at a gravel processing plant is modeled by GOT. T is in hours and 0 to 8. At the beginning of the day, the plant has 500 tons of unprocessed gravel.
That's our
Times
CI.
zero.
Okay.
So that's the start.
At time 0, that's an initial condition.
That's what we use for fine C.
During the hours of operation, the plant processes gravel at a constant rate of 100 tons per hour. Okay. So you've got gravel coming in. So you start at 500, you're subtracting 100 an hour, and adding whatever this function gives you. Right? Okay. So find G prime at 5. Using correct units, interpret your answer in context. So calculator, how would you do G prime at 5? Math 8. Y1 5.
That's it.
Oh, that's how you do equivalent, huh? You do alpha to.
Alpha. Should I do this as well?
Negative 24.58. And 24.587.
I don't know.
That's what I would have done something the other day.
What'd you get?
Negative 24.587.
Okay. Want that, we want that mode, make sure we're in radians, okay. And math 8, dx, grab y1 at 5. So, everybody got that? All right, so negative 24.587, remember round to 3. Interpret that in the context.
Rate the gravel rise.
Is what?
Negative 24.587.
Close. This is a derivative of a rate,
Oh.
right? So that's an acceleration issue. So the rate at which the gravel will rise is decreasing by, negative is increasing. So is decreasing by 24.587 tons squared. Ralph?
If you're writing that in words, would you have to say tons squared, right?
They don't ask, oh, they do ask for units. So yeah.
Ah.
Okay, so keep that in mind. So you got negative 24.587. Okay, the rate at which gravel arrives at t equals 5 is decreasing by 24.587. Is that going to be tons per hour or tons squared? Tons squared is what makes sense.
That's an extra.
Or square per hour?
Tons per hour squared,
There you go.
right? Okay, that's what we gotta have. Why did I make that mistake? Find the total amount of unprocessed gravel that arrives at the plant during the hours of operation on this workday. This is the
Position.
okay. So for part B, find the total amount of unprocessed gravel that arrives at the plant. How do we do that?
9, 0, 8.
We always have to write it out. We have to write our problem out.
So the interval is 0 to 8. G of T at DT.
So,
I don't understand why the amount will.
Math, 9. 0, 8.
No.
Yeah.
No, she's 20. Just take it back.
That's a lot of tons of gravel. Your typical dump truck will haul 15 to 16 tons. So you're looking at 60, 50 to 60 dump truck loads. Which, when you're bringing in those big semis that haul gravel, they're gonna haul 50 tons. No, 30, about 30. At minimum of 30 tons, so twice a dump truck. Right? So they can move some rock. We've got a gravel, a pit across from our place, and there's no more, their permit is expired, so all they can do is haul what's out, what's already processed, and it's disappeared fast. Okay, is the amount of unprocessed gravel at the plant increasing or decreasing at time 5?
Sign analysis of G of T because it's the rate function.
Well, we know the rate is decreasing, right? What's the rate at which gravel's arriving? Yeah, so, right, G of 5. You guys know how to do a value in your calculator, right?
No.
Alpha, trace.
No,
Then you put
it's
parentheses.
second, yeah, second trace. Calculate, menu, value.
But you need a graph for that.
You know,
Well, I always say you need to like actually see the graph.
All your names.
Positive.
so. Yeah, we're not gonna be able to see.
No, it's like way the heck up.
98.14 is arriving.
Positive.
Okay, how much is leaving? 100. So we are decreasing.
Student, where
Yeah.
from the beginning?
Not stupid word problem.
Well, I didn't see the 100 for
We underlined it. Or we annotated. Okay. And then we can also go into what is the maximum amount of unprocessed gravel at the plant during hours of operation in this workday. So how do we find total amount?
The integral from 0 to 8 minus 800, because you get rid of it. Yeah. Part B minus 100 times 8.
Okay, so there's the total amount processed, right? For an 8-hour day. How do we find a maximum of that? How do you find the maximum of a function? Derive it.
So you look for G of T.
That's what I'm thinking about this one.
Oh, that's right.
Oh, G of T is the derivative, right? That's fantastic. Where's G of T? So, derive it. Equals 0. Okay, that's a calculator problem. Find the zeros of G from 0 to 8. Okay. Remember your zoom fit function. We'll see if that works.
That'll work. That one will. So you can't. 0.
Something's not right here. Oh,
No sign.
something's not right here. Okay. All we're worried about is the unprocessed gravel, right?
Yeah.
What I have on the board was right, wasn't it?
So,
Why am I confused? I don't know why I'm confused. Something's not working right up here right now.
what is the math?
Okay, I give. I'm not gonna do this right now.
You wouldn't, would you do the
I'm
rate?
gonna
like,
cheat.
Wouldn't you go to the integral and then,
Oh, this is not 2016. This is 2013. Okay, so we got everything right so far. Yeah, I had it.
problem we were working on?
We're on D. Why would they put 100 in here?
Why would you put the 100 in here?
That's what I'm wondering.
Because it's 100.
See, something's just not making sense to me.
Because the rate at which gravel leaves is 100 per hour.
Oh,
The rate of that, it's not like a set.
yeah. It's a set value, but what I had on the board was taking all 800 out at once. Okay, so yeah, that was my mistake. We needed to put 100 in the function. Okay, that's the tough, there's always the tough part, right?
Because you were doing, at the end of the
Yeah.
day, how much is your unprocessed gravel?
That's what I was calculating. So, yeah, so your integral will end up, your derivative will be g of t minus 100, right? So where is, basically,
Is that darn
Set-
theorem again?
equal to 0.
Squeeze theorem?
No.
No.
And then this is the candidates test. So g of t minus 100 equals 0. So where is g of t equal to 100?
The one we did yesterday.
And then do the candidates test for those values. Okay.
Oh boy, I'm that stupid. Whoops.
It's usually my pre-calc class.
I just picked it up, man.
Okay, does that make sense? Like the mistake that we or I made, putting that 100 outside the integral. Because we want at some moment, and I was calculating at the end of the day.
I don't understand how they went from A of t to A prime t.
It's the fundamental theorem of calculus.
Yeah, but isn't the
Part
preset of that A at 0 has to equal 0? Or A at...
It does, 0 to 0.
What? I don't understand that at all.
So when you derive this, right, it will output that function as your derivative as long as at time 0, the area is 0, the value is 0. The integral from 0 to 0, right? So this is all its output when you derive it. Set it equal to 0 to find a maximum. You get your t value and then use the candidates test because this is an absolute min-max problem. Okay. Pretty sure that's why I don't earn 100% on AP calculus exams, because I do something every time. All right. Questions about today?